Now that we have an understanding of how to do some operations with polynomials, we're going to take a step back for a moment and talk about something called the greatest common factor. So the greatest common factor is essentially a common factor within a set of numbers or terms that we can divide out evenly. But because we are looking for the greatest common factor, we're looking for the largest factor in terms of value, typically that we can factor out of a set of numbers or terms. So taking a look at example 1, we're asked, using method 1, determine the greatest common factor of the following. Also GCF, that's just an abbreviation for greatest common factor. So looking at example 1, I'm going to be teaching 2 different methods. As you can see in example 1, it says method 1. So for this first method that we're going to use, we're not going to, beyond this video, we're not going to really use method 1. But this method is very useful in terms of understanding what exactly is a greatest common factor, because method 2 can sometimes, it's like the more shortcut way of figuring out what it is. But sometimes these ways of like shortcuts, quote unquote, can kind of like make us not understand what the stuff actually means and like what we're doing. So that's why we're doing this method 1 first. So for this first method, we're simply just going to write out the factors of both 16 and 24. So the factors of 16 are 1, 2, 4, 8, and 16. Now for the factors of 24, those are 1, 2, 3, 6, 8, 12, and 24. So now that we've written out both the factors for 16 and 24, we have to determine what the greatest common factor between 16 and 24. So we have to look for a common factor. We have to find the largest common factor in both 16 and 24. So we got a 1 in common, a 2 in common. We have a 4 here, no 4 here. We have an 8 here. We have an 8 here, so those look good. Let's take a look real quick. We have a factor of 16 for 24, and we don't. So since we don't have a factor of 16 for 24, our largest common factor here is 8 for both 16 and 24. So our GCF is 8. Looking at example 2, we have 30, 42, and 28. So let's write out our factors. So we have 30, and our factors for 30 are 1, 2, 3, 5, 6, 10, 15, and 30. For 42, our factors are 1, 2, 3, 6, 7, 14, 21, and 42. And then for 28, our factors are 1, 2, 4, 7, 14, and 28. So now that I've written out all these factors, I encourage you to pause the video and see if you can find the greatest common factor. And assuming you have given it a go, the greatest common factor in this case is actually only 2. There's no other factor from these 3 numbers that matches up, or there's no other factor that's larger than 2 in all 3 of these numbers. So 2 is our greatest common factor in this case. And that's it. Alrighty, so for example 2, now let's use a different method to help us find the greatest common factor. So for this set of number, for example, 2, or well, I should say example 3 here, we have 57, 33, and 45. So I'm going to first start off by just writing out the numbers. We're going to have 57, 33, and 45. And I'm going to write a bar kind of like this. And then I have to look at these numbers that we have here. And I have to think to myself, what number divides evenly into all 3 of these numbers here? And they're all odd, so based off the fact that they're all odd, I'm going to see if I can divide them by 3. And it just so happens that all of them are divisible by 3. So when I go ahead and do that, I'm going to write 3 here out on the side to denote that I'm dividing all these by 3. And then I'm going to divide all the numbers by 3 and put the results down here. So 57 divided by 3 is 19. 33 divided by 3 is 11. And 45 divided by 3 is 15. And now once we get here, we have to ask ourselves, is there a number we can divide all 3 of these numbers by? That'll get us whole numbers. And the answer is no. We can't divide these numbers out any further. So in this case, our greatest common factor is whatever we have out on the side here, and it just so happens to be 3. So our greatest common factor is just 3. Now looking at example 4, I encourage you to pause the video and try this one on your own. And assuming you have given it a go, let's go through it. So we have the numbers 80, 72, and 120. So I'm just going to go ahead and write that out here. And because all these numbers are even, I'm going to see if they're divisible by 4. And it just so happens that all 3 of these numbers are divisible by 4. So writing the numbers down here, we're going to have 80 divided by 4, which is 20. 72 divided by 4 is 18. And 120 divided by 4 is 30. Now looking at the resulting numbers down here, can we divide all 3 of these numbers by a set number, or are all 3 of these numbers divisible by a certain number? And they are. We can go ahead and divide all 3 of these numbers by 2 because they're all even. So 20 divided by 2 is 10, 18 divided by 2 is 9, and 30 divided by 2 is 15. And can we divide, is there a number that's divisible by all 3 of these? There isn't. So in this case, we're done here. And our greatest common factor is going to be the product of the numbers that are on the side here. So our greatest common factor in this case is 4 times 2, which is 8. Alrighty. So now that we have a feel for finding greatest common factor for sets of just numbers on their own, we're now going to introduce variables and finding greatest common factors with those. And the process doesn't really change. The only thing that you have to worry about is this quotient rule here of exponents. So remember, when you divide something that has the same base, you just simply subtract the exponents. You won't really have to use the product rule here, so I don't know why I have it. You won't have to use the product rule here in this section. But without further ado, let's go through it. So for example 5, we have x and x squared. So as always, I'm just going to go ahead and write out the x and the x squared, and I'm going to write this bar here. Now notice both these terms here, this x and this x squared, they both have an x, right? So I'm going to go ahead and divide both of them by x. So here we're going to get x. I'm going to actually write out what I'm dividing here so that way it's more clear to us, because now that we're dealing with variables, it can be it can be less intuitive. So here we're going to have x divided by x, and then here we're going to do x squared divided by x. And when we do that, here, let me go like this. And when we do that, we're going to get, well, here, these end up canceling. So what ends up happening is we just get 1 here. And then here we have x squared divided by x, which is x to the power of 2 minus 1, which is x. So I'm just going to go ahead and write that x here. And because looking at these two terms now, we have to ask ourselves, is there another common term that we can divide both of them out by? And there's not. So in this case, we're done here. So our greatest common factor is just x. Looking at example number 6, we have x squared and x to the 4th power. So I'm going to go ahead, write that out here, do the bar, and I know I could factor out an x like I did in example 5. But what I'm going to do is I'm going to divide all of both of these by x squared. And just as a little hint to set you up for success, whenever you're doing greatest common factor problems, simply always just divide by the smallest exponent that's in the problem. So like here, notice we divided by an x, and an x just has an invisible power of 1. So I didn't factor out, I divided both these terms by just that power of 1. Here I'm going to divide both these terms by the smallest power, which is 2. So when you do that, you get x squared divided by x squared here, which that just becomes 1. And x to the 4th divided by x squared, that becomes 4 minus 2, which is 2. So down here, we get x squared. And our greatest common factors here off to the side, which is x squared. Now looking at example number 7, we have 3x squared and 6x cubed. I encourage you to pause the video and try this one on your own. We haven't done an example yet with both numbers and variables, but the process is still the same. You'll just have to think, what number can I divide out of 3 and 6, and what variable or what can we divide both these variables by? So it's going to have both of what we've done so far involved. And assuming you have given it a go, let's go through it. So we have 3x squared and 6x cubed. So looking at this, we can look at the numbers or the coefficients that we have. We have a 3 and a 6, and I can identify that I can divide both 3 and 6 by 3. So I'm going to write that out here. And when I do that, 3 divided by 3 is just 1, so we're going to be left with x squared. I'm going to write that 3 closer here. And then here, 6 divided by 3, well, that's just 2. And I'm going to carry that x cubed. And now here, now I have to look at the variables. We have an x squared and an x cubed. And as always, I'm going to divide out by the smallest exponent that we have, which is 2. So we're going to divide out x squared. X squared divided by x squared is 1. 2x cubed divided by x squared, that ends up becoming 2x. So now here, the greatest common factor is the product of these two. So we're going to have 3 times x squared, or in other words, just 3x squared. Looking at example number 8, I encourage you to pause the video and try this one on your own. And now let's go through this together. So I'm going to write out all of our terms. So we have 10x to the 5th, 15x to the 8th, and 15x to the 4th power. Now looking at all three of these terms, I can tell that they're all divisible by 5 just by looking at it. And then looking at our variables and the powers, the smallest power is 4. So I'm going to go ahead and divide all the terms by x to the 4th. So when I do that, I'm going to have to first divide out our numbers. So 10 divided by 5 is 2. And then x to the 5th divided by x to the 4th just becomes x. And here, 15 divided by 5 is 3. And x to the 8th divided by x to the 4th becomes x to the 4th. And then here, 15 divided by 5 is 3. And x to the fourth divided by x to the fourth just cancels. So we don't have a variable for this term here. And looking at all three of these terms that we have here, or not terms, all three of these monomials that we have here, there's not a common factor that we can divide out anymore. So this here is our greatest common factor. So our greatest common factor is 5x to the fourth. Alrighty, and for our final example, we have 21x, 7, and 14x squared. As always, pause the video and try this one on your own and see if you can get it correct. And assuming you have tried it on your own, let's go through this. So, looking at all of our terms, this middle term here, or sorry, my apologies, not term, this middle expression here, 7, does not have a variable. So we can't divide out that variable. We can't take out a variable, or we can't divide all three terms by a variable because there's not a variable here. So in this case, all we can divide all three of these terms by is a number. And it just so happens that all three of these expressions are divisible by 7. So let's go ahead and divide them all by 7. 21 divided by 7 is 3. Bring that x. 7 divided by 7 is 1. 14 divided by 7 is 2. And then I'm just going to carry down that x squared. And there's not any other term or any other common factor that we can divide out by all three of these expressions. So our greatest common factor in this case is just simply 7. And that's it.